The cosmos is not as silent as you might think. Beyond the shimmering stars and sprawling galaxies, space is filled with a symphony of strange and mysterious sounds. These otherworldly noises have been captured by satellites and space probes, and they're waiting to be explored. Join us as we journey into the unknown. In the vast, silent expanse of space, the unexpected crackle of sounds has occasionally been picked up by our instruments. These detections, often accidental, have opened new windows into the mysteries beyond our planet. The first of these surprising signals were not what scientists were originally looking for. They were found by instruments designed to study other phenomena, turning up unexpected data that piqued the curiosity of researchers. One of the most famous early detections came from the Voyager spacecraft. As it traveled through the outer planets, its instruments captured the eerie, whistling sounds of plasma waves in the magnetospheres of Jupiter and Saturn. These sounds, translated into audible frequencies, resemble ghostly whistles and crackles. They are created by the interaction of charged particles with the planet's magnetic fields. The Voyager's plasma wave instrument, designed to study the space environment, accidentally turned into a cosmic radio receiver. Another intriguing detection came from the Cassini spacecraft. While studying the rings of Saturn, its radio and plasma wave instrument picked up strange, rhythmic sounds. These were later found to be the result of interactions between the rings and Saturn's magnetic field. The sounds, when converted into audio, resemble a haunting symphony. This was not what the instrument was primarily designed for, but it provided valuable insights into the dynamics of Saturn's rings. These early detections were merely the beginning. They showed that space is not as silent as once thought. By converting these signals into sounds, scientists could better understand the complex interactions happening in the cosmos. The instruments, originally meant for other purposes, became invaluable tools in the study of these unexpected phenomena. Each detection added a new layer to our understanding of the universe, proving that sometimes the most exciting discoveries are the ones we don't plan for. Sound travels differently in space than it does on Earth. In the vast, airless void, there are no vibrations like those that create sound waves in our atmosphere. Yet, scientists have recorded unusual frequencies beyond our planet. These are not sounds as we typically understand them, but rather, they are electromagnetic signals, radio waves, or other types of energy that can be translated into sound. NASA's Voyager and Cassini spacecraft have picked up strange radio emissions from planets like Jupiter and Saturn. These emissions are in the kilohertz and megahertz ranges, far beyond the human hearing range. To make sense of these signals, scientists use a process called data sonification. This involves converting the frequencies of these emissions into audible sounds. For instance, the eerie, whistling sounds from Jupiter's magnetosphere are created by translating these high-frequency radio waves into a range that our ears can detect. The Cassini spacecraft also recorded unique sounds from Saturn. These are not direct recordings of sound, but rather, they are plasma waves detected by the spacecraft's instruments. Plasma waves are disturbances in the electric and magnetic fields of a planet's magnetosphere. When these waves are converted into audio, they produce haunting, otherworldly sounds. Similarly, the Chandra Tenth-Ray Observatory has captured sounds from distant galaxy clusters. These sounds are created by translating the pressure waves from the hot gas in these clusters into the audible range. The result is a deep, resonant hum that offers a unique way to experience the cosmos. When scientists detect unusual sounds in space, one of the first steps is to rule out any sources that might be familiar or man-made. This process is crucial to ensure that the sounds are truly extraterrestrial and not just interference from our own technology. For instance, the space roars detected by NASA's Voyager and WIND spacecraft were initially puzzling. However, thorough investigation revealed that these sounds were not alien in origin but rather the result of plasma waves interacting with the solar wind. This finding helps scientists better understand the behavior of charged particles in space. In other cases, sounds picked up by satellites or deep space probes have been traced back to natural phenomena within our own solar system. For example, the Juno spacecraft captured eerie, whistling sounds as it approached Jupiter. These sounds were later identified as electromagnetic waves generated by the planet's massive magnetic field interacting with charged particles. Similarly, the Cassini spacecraft recorded strange radio emissions from Saturn's rings, which were found to be the result of tiny particles within the rings colliding and producing electrical charges. These discoveries highlight the importance of meticulous investigation to distinguish between alien and familiar sources. Human-made interference is another common culprit that must be excluded. Satellites and space probes are equipped with sophisticated instruments designed to filter out signals from Earth. However, occasional glitches or unexpected interference can still occur. For example, the Kepler Space Telescope, which was designed to search for exoplanets, sometimes picked up signals that were later traced back to Earth-based sources. This underscores the need for rigorous data analysis and cross-verification to ensure that the sounds recorded are indeed from beyond our planet. By systematically ruling out mechanical and human interference, scientists can focus on the truly mysterious and potentially groundbreaking sounds that originate from the far reaches of the universe. The cosmos is a symphony of sounds, with many originating from natural phenomena. Planets, stars, and even the vast emptiness of space produce a variety of noises. For instance, the gas giants like Jupiter and Saturn emit radio waves that can be translated into sounds. These emissions are often caused by the interaction between the planet's magnetic fields and charged particles from the solar wind. The result is a hiss, crackle, or even a whistling sound. Stars, too, have their own unique sounds. The Sun, our closest star, produces sound waves that bounce around inside it. These waves create a humming noise, similar to a large, deep bell. Scientists have even been able to translate these waves into audible sounds, revealing a deep, resonant hum. Beyond our solar system, the cosmos is filled with other natural sources of sound. Pulsars, which are rapidly spinning neutron stars, emit regular pulses of radio waves. These pulses can be translated into a rhythmic, beeping sound. Supernovae, the explosive deaths of massive stars, also produce sound waves. Although these sounds are too low in pitch for human ears to detect, they can be translated into audible frequencies, revealing a deep, rumbling noise. In the vast expanse of space, signals from distant cosmic bodies have been detected, carrying patterns and rhythms that challenge our current understanding of the universe. These signals often exhibit periodicities or structures that do not align with any known astrophysical processes. For instance, fast radio bursts, FRBs, are intense pulses of radio waves that last for a few milliseconds. Some FRBs repeat in seemingly irregular intervals, defying the predictable patterns we observe in most celestial phenomena. One of the most intriguing examples is the signal known as Fast Radio Burst 121102, which was first detected in 2012. This FRB exhibits a complex pattern of repetition, with bursts clustered together and then followed by periods of silence. The clustering itself shows a periodic rhythm, repeating every 157 days. Such a pattern is unprecedented and does not fit neatly into any established theories. Scientists are still grappling to explain these rhythms, often resorting to hypotheses that push the boundaries of known physics. Another fascinating case involves the enigmatic signals from distant stars, particularly the mysterious Tabby star, or KIC 846-2852. This star exhibits irregular dimming patterns that do not correspond to any known astronomical events. The dimming occurs in no particular rhythm or pattern, making it difficult to attribute to natural causes like orbiting planets or dust clouds. Some have speculated about exotic explanations, such as the presence of massive structures or alien megastructures, though these ideas remain purely speculative. These unusual patterns and rhythms serve as a reminder of how much we still have to learn about the universe. They challenge our existing models and force us to reconsider our assumptions. As technology advances, we may uncover new mechanisms or phenomena that can explain these baffling signals. Until then, they remain a tantalizing mystery, beckoning us to explore the unknown and push the limits of our understanding. The internet erupted when NASA shared an audio clip captured by the InSight lander on Mars. The low-pitched sounds, akin to a distant rumble or a deep drone, sent shivers down the spines of many. Some listeners reported feelings of unease, attributing the eerie sounds to something otherworldly. Fear gripped a small but vocal minority, sparking wild theories on social media platforms. Conspiracy theories flourished, with some suggesting the sounds were evidence of alien activity or even distant screams. The unease was palpable, with some listeners reporting sleepless nights after hearing the haunting sounds. Yet, for every person fearful of the unknown, there were many more who were captivated by the mystery. The sounds became a hot topic on forums and social media, with people sharing their interpretations and theories. Some compared the sounds to those of distant thunder, while others likened them to the hum of a large engine. The fascination was not just about the sounds themselves, but also about the technological marvel that made their capture possible. People were in awe of the advanced instruments that could pick up such faint signals from another planet. This sense of wonder and curiosity drove many to delve deeper into the science behind the recordings. The public's reaction was a mix of fear and fascination. reflecting humanity's complex relationship with the unknown. While some were terrified of what the sounds might represent, others were enthralled by the possibility of unraveling new mysteries. This duality was evident in the countless discussions, debates, and memes that flooded the internet. The sounds from Mars became a cultural phenomenon, sparking a renewed interest in space exploration. They served as a reminder of the vast, uncharted territories that lie beyond our planet, waiting to be discovered and understood. The fear and fascination they evoked were a testament to human nature, our innate curiosity, and our deep-seated desire to explore the cosmos. The universe is filled with whispers and hums that challenge our understanding. Scientists capture these sounds, but interpreting them often leads to discomfort. The main issue is that these sounds don't have earthly equivalents. A burst of radio waves from a distant galaxy, for instance, might not resemble anything we've heard before. This lack of reference points makes interpretation tricky. Researchers might compare these sounds to familiar ones, like a whale song or a cracking iceberg. However, these comparisons are often loose and can lead to misunderstandings. Take the low-frequency hum detected by the European Space Agency's Goche satellite. Scientists initially struggled to interpret it. Some thought it was a technical glitch. Others considered it a new phenomenon. It took time to realize it was the Earth's own magnetic field interacting with the solar wind. This example shows how initial interpretations can be off the mark. It also highlights the uncertainty that comes with exploring the unknown. Even with advanced technology, scientists are often left scratching their heads. Another challenge is the sheer distance these sounds travel. By the time they reach us, they are often distorted. It's like trying to understand a conversation from the other side of a crowded room. The lack of context adds to the discomfort. For example, fast radio bursts, FRBs, are intense pulses of radio waves that last milliseconds. They are often one-off events. This makes it hard to study them in detail. Some scientists have even speculated about extraterrestrial origins. Yet, there's no concrete evidence to support this. Such speculations show the limits of interpretation. They also underscore the need for caution. Sound has a profound impact on our emotions, often triggering deep-seated feelings and reactions. This is why strange sounds recorded beyond our planet remain so unsettling. These sounds, often referred to as space sounds, are not actually sounds in the traditional sense. Since space is a vacuum, it cannot carry sound waves like air does on Earth. Instead, these sounds are vibrations captured by spacecraft instruments and translated into audio frequencies that humans can hear. This process, known as data sonification, converts complex data into sound, making it more accessible and interpretable. The unsettling nature of these space sounds can be attributed to their otherworldly qualities. They often lack the familiar patterns and rhythms of earthly sounds, which can create a sense of unease. For instance, the eerie whistles and chirps recorded by NASA's Voyager spacecraft as it passed through the outer planets are unlike anything we encounter on Earth. These sounds can evoke feelings of mystery, isolation, and even fear. The human brain is wired to respond to unfamiliar sounds with caution, as a survival mechanism. This is why these space sounds can be so unsettling, as they trigger our primal instincts. Moreover, sound can also act as an emotional trigger due to its ability to bypass the rational brain and connect directly with the limbic system, the part of the brain responsible for emotions. This is why certain sounds can instantly evoke strong emotional responses. For example, a sudden loud noise can trigger a fight or flight response, even if there is no immediate danger. Similarly, the strange sounds from space can tap into this primal response, creating a sense of unease or discomfort. This is particularly true for sounds that are low in frequency, as these can mimic the sounds of large, potentially dangerous creatures or natural phenomena. Additionally, the context in which these sounds are presented can also amplify their emotional impact. When we hear these strange sounds from space, we are often reminded of the vastness and mystery of the universe. This can evoke feelings of awe, wonder, and even existential dread. The combination of these factors makes the strange sounds recorded beyond our planet so unsettling. They tap into our deepest emotions, triggering responses that are both primal and profound. As we've journeyed through the cosmos, we've encountered a symphony of strange sounds that challenge our understanding of the universe. From the eerie whistles of pulsars to the haunting echoes of distant exoplanets, these sounds remind us that space is not as silent as we once thought. They whisper secrets of cosmic phenomena, inviting us to listen, to learn, and to explore. So, keep your ears tuned to the cosmos, because who knows what other mysterious sounds are waiting to be discovered. Remember to like, share, and subscribe for more cosmic journeys. Until next time, keep looking up and keep listening to the sounds of the universe.